Hi, my name is Eugene Kim. I prepared the paper which is about the mobile intelligence in smart factory forming a trust-based team. Here is outline of the presentation. Firstly, I will introduce the method of forming a team in smart factory and the property of that. And then I will explain the new framework in this paper and simulation result. Finally, conclude with conclusion and future works. Smart factories are self and systematically productive systems developed by the first industrial revolution. This allows the work to be distributed across more processor units, enabling them to work more efficiently. In this smart factory, the AGV, called the auto-guided vehicle, can move objects, restore connectivity, or perform various manufacturing activities to the production line. This kind of device combines with several functions such as artificial intelligence and mobility communication technology to provide mobile intelligence. To ensure this flexibility, teams should be formed with likely freely moving vehicles, sensors, and smart devices in a suite of configurations for a given target. However, the key to enabling teaming within a smart factory is mobility and interaction. While this autonomy of technology makes it difficult to dynamically determine the right team. Therefore, in this paper, we present how to measure reliability based on efficiency and effectiveness and build the AGV team based on this. Scenarios typically consist of an environment with agents connected to multiple mobile intelligent devices. First, consider production lines that require cooperation between smart AGVs and human workers. For example, if there are work areas where smart factories and cars are assembled, as shown in the first picture, movement through each area enables collaboration between multiple devices and people in the production line for assembling products. And the proposed scenario assumes that there are different numbers of smart AGVs because they depend on the processing techniques adopted. These are different types of efficiency values and transportation. In this paper, we first measure reliability and reputation, which is calculated based on published feedback on AGV activities in the factory. And then we design a trust framework by leveraging defined actions to self-performing team. AGV effectiveness refers to the level that AGV has received from the customer. And AGV efficiency is the ability of the smart AGV to perform one or more specific tasks correctly on the production line. Finally, reliability combines those efficiency and effectiveness to obtain a single synthetic measure that characterizes a particular agent, so it can be confirmed as follows formulas. Next, we will discuss how to build the AGV team within a smart factory using the trust model we discussed earlier. First, the framework allows the software agent to connect to each AGV to store and share the effectiveness, efficiency, trust information through the manufacturing manager agent (MM) agent. This frees it from the need for a centralized server and its consequent disadvantages. It also has the advantage of allowing forming a team by taking into account all the AGB results of the present past. This process is divided into 5 major categories. The first one is formation assignment task. Agent receives the association that makes up the team by the administrator. It generates some inputs. Okay, the number of agents recurring forming a team. Maximum allowed time to wait before starting it, and minimum trust value required for each AGB. Second is request task. Agents send the request to before and the request for time availability. And then third stage is response task. Based on earlier request, each agent sends computed values to agent. The first is selection task. agent continuously monitors the list, which includes all response received by each other agent, and then it calculates some values. Finally, last stage team formation task will be implemented. agent tests the list and provides a response to administrator. In this paper, the environment is set as follows. The record parameters were also set to the initial values. This is simulation results as shown in the figure. For example, in the first and second graph means about effectiveness and efficiency showed a very small sensitivity to loss. This means that AGB delivers high performance and high efficiency at the same time. And in the figure on the right, the reliability of the 3 AGBs is measured, such as in better condition and medium condition and worse condition, according to certain loss values. And this shows the graph of the accumulated advantages of 3 components: effectiveness, efficiency, and reliability. Light 1 is showing the average daily loss of time for AGB, because in this paper it is not optimized with the TA, time availability. As a result, here we present a new framework based on efficiency, effectiveness, and reliability. Based on this, it improved the challenges of building AGV teams on mobile, as well as distributed environment smart factories. We have identified that the proposed framework improves performance in terms of effectiveness and efficiency. However, it is not optimized in terms of time availability. Also, it is necessary to experiment with the real environment. So, future works will be implemented about this. Thank you for listening.